This is 6.4 graphs of sine and cosine functions. We just got done learning the unit circle, and one of the big things that I try to emphasize to you, every point, we typically learned in xy, but remember it's cosine, then sine. Okay, every single one of these points, this is the cosine of 30 degrees. That's the sine of 30 degrees. That's the cosine of 0 degrees, or 360, and that's the sine of 0 degrees, the sine of 0. So we learned that, and I can do that all the way around the circle if I wanted to. So we learned that already, but the big emphasis, again, is to make sure you understand every point is sine and cosine. Now, if I wanted to make a separate, if I just take a look at just all the, let's start with sine. All right, so if I started doing the sine of 0 degrees, and I write that down, remember the sine is the second one, 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 and if you pay attention to that, I'm just going to basically make a chart of those numbers. So the sine of 0 degrees is, if you look at it, it's 0. The sine of 0 is 0. The sine of 30 degrees is 1/2. The sine of 60 degrees is the square root of 2 over 2. The sine of, that was 45, sorry. The sine of 45 is that. I knew there was something wrong when I wrote it. I'm like, wait a minute, that's hard. All right, so sine of 60 is the square root of 3 over 2. And the sine of 90. Now, I'm not going to go all the way around, but I want you to understand what I'm doing. The sine of 90 would be 1. And then if I keep going around, if I'm just going to highlight certain ones specifically. I could keep going around if I wanted to, but 180, 270, and of course, 360, 0, 90. If you're aware of those, it's going to help you out a lot to be able to do that, to be able to graph what we're about ready to do. So I also know the sine of 180. Sine of 180 is 0. The sine of 270 is -1. And again, sine of 0 degrees is the same as sine of 360. It's still 0. So I've made all the way around a complete circle. And again, I could record every one of those points if I wanted to. Now, let's look at a graph of just those, the sine function. What I'm interested in is, like, what if I graph the sine function? The sine of x, or, remember this can be theta, or whatever letter we want to use for representing the angle. So if we wanted to graph this function, and we're going to basically take these values, just the sine values, when I plug in 0, when I plug in 30 degrees, again, that's my theta, I get 1/2. So that's really what I'm looking at, and I'm going to plot those. And then 45, get that, 60, get that, 90, get that, 180, get that, and those are points, and we're going to graph that function. So let's look at those just to make sure, see what the sine function looks like. So we're going to graph the sine function. And, we already said, like, when we plug in 0 degrees, we're going to get 0. So this point is right here. This is your y line, and this is your x line. And notice what we're going to basically do is we're going to go one complete circle on the unit circle, one complete cycle around. And, think of this as like your XY chart. So you're putting your 0 degrees in. And let's pay attention to just one complete circle. So in other words, we're going to go all the way to 360 degrees, and we know we're going to get 0 again. Okay, so we're going to go all the way, and then we're going to literally divide this in half as 180. And at 180, you're going to get 0. We're going to go half of that, and we're actually going to get 1, and then 270. and you're going to get negative 1. Again, go back and look at that chart, but you'll see it. So basically what we're going to do is we're going to go all the way to 360. We know we're going to get 0. We're going to go half of that is 180. This is 0 right here. And we're going to get 0. Half of that is 90. And we're actually going to get, at 90 degrees, it's going to be 1. So this is pi of 1. And at 270, we're going to get negative 1. 70. Now, this function, if I graphed it, and by the way, we could go back and graph all of the points if we wanted to, like literally every single one of them, but it's going to look like this. It's going to start at 0, 0, and it's going to go up to this, curve around, those major points. That's what the sine function looks like. Now, what I just now graphed is one complete circle all the way around. I started at 0 degrees. I went to 90 degrees. Then I went to 180. Then I went to 270. And then I came back to 360. So I did one complete cycle or period. It's called period. So I've done one period of sine. And so I basically ended up where I started at. And again, we could do a little bit more specific points if we wanted to. So for instance, we know that at 30 degrees, it was at 1/2. The sine of 30 is 1/2. So we could go to 30 degrees, right about here, if we wanted to, and that would be about 1/2. That would literally 1/2 up. We could fill in a bunch of those. We could fill in 60, we could fill in 120, 150, but it would be along that trig function, the sine function, and every one of those points would be along that trig function. So basically, if you remember the four things, the 0 degrees, the 90, the 180, the 270, then you could basically graph the sine function. And again, knowing, if you want to know the 45, the 30, the 60, if you want to know those, you can graph those as well to make it more accurate. But the sine function is going to look like that, and that's one period. Now, if we continued the sine function, because remember, we can go one complete circle around, but we could go 2 times around the circle. We could go 3 times around the circle. We can go 4 times around the circle. So this function, the sine function. And by the way, we can go negative too. Remember, on the circle, we can go this direction too. We can go counterclockwise in the negative direction. So, just so you understand what the sine function looks like. So here's 360, one complete cycle. Half of that is 180. Half of that is 90. Halfway between here is 270. And one complete cycle, one period. Again, here's 1 and here's negative 1. And that's one complete period right there. And then, but again, we can keep going around the, around the circle, and it would just keep adding, and it's going to keep looking like this. The sine function is going to keep looking like this. It keeps going on. If I wanted to plug in 540 degrees, if I wanted to plug in 720 degrees, the sine of that, it would just be further along. And then I can also go in the negative direction. So if, again, it would look like negative 90 degrees, negative 180, negative 270, negative 360, and then it would just literally go down to negative 1, back to 0, up to 1, and then again, it keeps going, the sine function keeps going, okay? But again, it starts at 0, 0, and you can see that from the unit circle. That's the sine function. So this is literally y equals sine of x. Again, starts at 0, 0, and then follow us along. Okay? Now again, from here to here is one period. Let me emphasize the one period. So from it started here to here, that's one period. Okay, so from here to here is one period. One complete circle is one period. And so here's another period, here's another period. So there's actually one, two, three periods there. And again, I don't want you to take the asymptotes, vertical asymptotes, but there's three periods on the positive side. And again, I can go back to, when it completes a complete cycle, that's another period, and then here's another period as well. So, I have several periods graphed on this sine function, but it keeps going on forever. Now, likewise, the cosine function. So if you go back and do the unit circle, but pay attention to the sine function, or the cosine. So cosine of 0 is 1. Cosine of this, cosine, 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 and you can go all the way around and graph the cosine function the exact same way. So the cosine function, again, cosine of like 0 degrees. Okay, so 0 degrees is just cosine x. So cosine of 0 degrees, well, cosine of 0 is at 1. And then if you notice, if you just pay attention to the main parts, 0 degrees, 90 degrees, 180, 270. Again, you can plug in all the other ones if you want to, but those are the four main ones you need to pay attention to. So cosine of 90 degrees is 0. Cosine of 180 is negative 1. 270 is 0. And 360 is back at 1. So if you notice this graph, so this is the cosine function. So the cosine function actually starts at 0, it's at 1. So there's the starting spot right there, 0, 1. And then again, the full complete cycle, one period, is the 360. Divide that in half, it's 180. Divide that in half, that's 90. And then divide this one in half, it's 270. It's just going to complete the cycle, but it's going to start here. Notice at 90, it's at 0. At 180, it's down at negative 1. I'm here at negative 1. At 270, it's back at 0. And at 360, it's back at 1. So here, the cosine function is going to look like this. And that's one period of it. But again, if you graph it, again, if we go around the circle again and again and again and again and again, or the negative direction, negative direction, negative direction, it keeps going on forever. So the exact same thing, you have your 0, 0, and again, go to like 360, 180, 90, 270, and again, the cosine function starts at 1. So here's one period, starts here, goes to here, down to negative 1, up to here, and back up here. That's one period. And then, but again, it can keep going on. You can literally just, that's 720. That's 720. And then you can literally divide that in half, divide that in half, divide that in half. Keep doing the cycle here. It's going to go down to here, up to there, back up to 1. And the same thing with the negative direction. It would keep going like this. So that's how you graph the basic sine and cosine functions. It's all based on the unit circle.